Okay, over the last couple days, we have learned all of our transformations. What do we do when there's adding and subtracting? What do we do when there's multiplying? What do we do when there's negatives? And now we're putting it all together, and we're going to have more than one at a time happening in our function. The cheat sheet that you got will be a vital resource for you as we are getting used to how to do this. This is not on your note sheet, I get that, but it's incredibly important is understand that there actually is an order that you must attack your transformations. Not often will this catch you, but if you do your transformations out of order, a certain combination of transformations actually would result in getting the wrong picture at the end if you did not follow this order. So the very first thing you will always do is look for any reflections and take care of that. And again, that is because of a negative in our equation. Then I take care of any shrinks and stretches. That is from a multiplication in my equation. And the last thing that I will attack is right, left, up, or down, which would be any addition or subtraction in my equation. Now, as you guys are getting that written down, and again, I know that doesn't have a spot necessarily on our note sheet, but if you can consult your cheat sheet that I gave you earlier that has your parent functions, if you look at the back, you will notice that the three boxes we have are in the order that you are supposed to attack your transformations. So as you're doing this, if you just work top to bottom every single time you look at a problem and look at each box and say, hey, do I have negatives to cause a reflection? Yes or no? If I say yes, I take care of it. If I say no, I just move down to the next box. Do I have any multiplication to cause a shrink or a stretch? If I say yes, I take care of it. If I say no, I move down to the next box. Do I have any addition or subtraction? Do ILROUD, move my dots, okay? This, every time, just address each box, say, do I have that, yes or no? Move on. Okay, so on this first one, I'm going to take some nice notes as to how we attack this, and can be some very good, helpful notes for yours because it's not going to change. Every single time we're going to think through these 4 steps as we do this, okay? So it says graph each function, definitely focusing on the last part, describe the transformation in words. We will definitely focus on that for the next couple days as we prep for our DCA because it is very description and words heavy, but we'll get there at the end of this one. But our first function, f of x equals negative 3x absolute value of x plus 1, we start, remember, with step number 1, which is just to write the table of the parent function. So our parent function for this, can you get rid of all the distractions? What is our parent function? Absolute value of x, right? So if I don't know what that is, I'm going to go to my cheat sheet and look at the table. You can always recreate the table, but that's where we start, is we just write the table for our plain old absolute value of x. Okay. Step 2, we scan through our entire equation and we look for negatives, which would be reflections, right? So as we scan through this equation, do I have any negatives? Yes, I do, right? And remember, there is a difference between negative and subtraction. I'm talking just negatives here. Do I have a negative? Absolutely, I have a negative. I have a negative right here. And so this is our thought process. If I get to a box on my cheat sheet and it says, yes, I have this, your next question will always be to yourself, is it inside or outside? Every time, okay? So is our negative inside or outside? Outside, okay? So then we remember, okay, outside things always impact our y column, okay? So I'm going to go impact my y column. In my note sheet, it will also help me remember what that's described as. Outside is actually called an ROX. So that's part of my description in words on ROX. But it does impact my y column. My directions on here should now tell me to go down my Y column and change the sign on every number. So that's what I'm going to do, is I'm going to go down my Y column and change the sign on every number other than 0. Okay, step 3. I'm going to scan through my entire equation and look for any multiplication. Now, I'm saying look for any, guys, there can be more than one. There could have been more than one negative. So that's why I say scan through the entire thing, because you might have to do this twice. You might have an ROX and an ROY. It is possible to have more than one, okay? Multiplication, which is going to be a shrink or a stretch. Stretch, okay? Do I have any multiplication? Yes. Now, here is a very important note. What number are we multiplying by? 3. At this point, in step 2, we have already addressed the negative. That is taken care of. Your answer to this will always be a positive number. Always. Okay? Because we've already taken care of the negative part of it. So then again, I said yes to something. So my next question to myself is it inside or outside? And the answer is outside. Outside things impact my Y column. So I go to my Y column and I multiply by, again, my table, my little cheat sheet should tell me that I will multiply by exactly what number is there, right? So outside things I don't have to change, contrary to our warm-up where I did have to change it because it was inside. So I multiply by 3. So I'm going to go down this column, multiply everything by 3. Okay, now step 4, I'm going to put a little thing in here. This is just the practical advice on how is easiest to graph this. Step 4, before I actually get to the bottom box on here, is I'm just going to dot out the table. So I'm going to dot out the points that are my table and then start counting. Now, if I don't have any addition or subtraction, those points that I'm dotting out in step 4 is my graph. But if I have any addition or subtraction, I will now count that. So I'm going to, in my picture, then count any, wow, I cannot spell here, subtraction, which would be moving us right or left, or moving us up or down, right? That's our ill route. So at this point, once I've dotted out those points, I will count if I need to move them any further because I have any pluses or minuses. So I'm just going to go put -2, -6 on my picture. -2, -6 would be about here. -1, -3, -3, 0, 0, -1 or 1, -3, 2, -6. And then I ask myself, do I have any pluses or minuses? Do I have any add or subtract? And we do on this one, right? We have one last transformation. So again, we go to our ill route. We answer the question, is it inside or outside? Inside, right? Ill route, inside. Addition tells me we should move left, opposite of what it feels like it should be. So now I would take each of these individual points that I dotted out and move them left 1. My final points then would be here, here, here. If you want to use multiple colors in your picture, you are absolutely welcome to, or mark them differently, or whatever is going to make most sense to you. But that would be our final picture. I did not list all of my transformations down here, so let's list those. We already discussed the ROX. The second thing I did have a multiplication, right? We impacted our Y column. Anything that is outside or impacts my Y column is vertical. And then remember our rules for our description here. We'll use the word vertical or horizontal, followed by the word shrink or stretch, which will match the number I multiplied my table by. I multiplied my table by 3. 3 is a big number, so I should say stretch. And finally, as listed up here, left 1. When you are asked to write out your transformations, the order that you list them in does not matter. As long as they're all there, you're good. Questions for me? Okay, I'm not going to really write this out from here on out, but this is absolutely what you should do every single time. Parent table, think about negatives, think about multiplies, dot it out, count in your graph. Okay. All right, we're just going to look at a couple other variations here. Okay, I've got two more examples for us of this type of problem. This one is f of x equals 1/4 x quantity squared plus 2. Sometimes, again, it's a little bit of a hesitation. What is our parent function on this? X squared, right? So again, that's where I start. We ignore all the numbers that are going on in there. I just find the parent function hidden among the transformations, and it is an x squared. Remember that, and I love that you guys are consulting your cheat sheet. That's awesome. Keep doing that. Eventually, we're going to need to get off of that because when we get to our test in it's like 2.5 weeks from now, you will need to be able to create those tables on your own. You are not graphing on Monday, so we don't have to worry about that. But my parent function table, if I ever forget, I can just manually plug these into my function. -2 squared is 4. -1 squared is 1, 0, 1, 4. And we start at the top of our cheat sheet. That first box says I'm supposed to be scanning through my equation looking for negatives. Do I have any negatives in this one? No, so if I say no, I just moved on to the next box. There's nothing to do, okay? So then we move to the next box, which asks me, anywhere in our equation, do we have any multiply? Yes. So then I address that, okay? So we make the decision, is that multiplication inside or outside? This is always the one that gives us a hesitation. Is this inside or outside? Inside, right? Inside things impact which column? X, the X column, right? And inside things, we always have to think opposite, which you guys did a wonderful job in your warm-up. What number am I multiplying by? 4, right? The reciprocal. Go down my X column, multiply everything by 4. Okay, I've already looked for negatives. I've already looked for multiply. At this point, I would dot those out in my picture and then start looking for pluses and minuses. This one way runs off my graph here, so I don't have a lot of dots that because like -8,4 is like way off my graph. But isn't x squared a parabola? So this parabola is just like super wide because it got stretched horizontally. So -4, 1 is here, 0, 0, 4, 1, and I'm just lightly dotting that out because after I dot it out, I'm supposed to look for any pluses and minuses, which we have. Okay, is that 2 moving us left or up? Up, right? It's outside of my function. So I will take each of these dots and move them up 2. And it's really wide, but it is a nice smooth curve through there. Okay, the description part of it. I want you guys to take a second ahead of me and see if you can describe. We did 2 transformations. Can you get them correctly described? Match that. That's the correct. That's a big number. So you'd say stretch. Always match that number. Okay, doing a good job here, guys. Remember the rules for describing. The one that always is most challenging is the whole vertical versus horizontal, shrink, stretch, all of that. So the number, or the first word, horizontal versus vertical, is inside versus outside, right? Ours is inside. Inside things, we use the word horizontal. I will always use this word, this number to guide me, whatever I multiplied my table by. I multiplied my table by 4. So this word should match that. That's a big number, which means it is a stretch. The last thing we did, you guys told me in words already, was up 2. Any questions? Okay. We do have a good conversation to have on this one as well. I want you to try to just set up your parent table for me, and then we'll talk about what to impact here. Parent function should be square root of x. You guys all identify that correctly? This is one of the ones that does not go with all the rest of them. Most of them do like the -2 to 2 type of thing. But I can't square root of -2, can I? Nor do I want to figure out what the square root of 2 is, because I don't know what that is. Okay? This is one where we would slow down and strategically pick numbers for our table starting at 0. Nothing negative, because I can't square root a negative number. And then I would continue to pick perfect squares, like 1, 4, 9, square root them to get my answer, 0, 1, 2, 3. Now, I had not thought about this, but I see how it can be a confusion. As you go to step 2, it asks you, do you have any negatives? Yes, that's not the confusion part. The confusion part might happen on the question of, okay, is it inside or outside? Inside. Okay, can somebody see why somebody might be tempted to say outside? Does anyone see where that confusion may come in? It's outside of parentheses, and I've been like super hounding, like parentheses means inside, whatever, but that's for an exponential, right? This is a radical, and if it's under the radical bar, it is inside. So you guys obviously pegged it right away. That is inside, but I just wanted to make sure that I did address, because I now understand why somebody might say outside, because it's outside of parentheses. But it's not outside of our function, okay? So inside negative, we don't see an inside negative all that often. Is it described as an ROX or ROY? ROY, and inside things impact which column? Inside things always impact the same column, that is X. The ROY in which column to impact, again, that bothers people, but it is true. So I go down my X column, and I change the sign on everything. Move down to your next question. Do we have any multiply? Yes. Inside or outside? Outside, which impacts which column? Y. Will I multiply by 2 or by 1/2? Those are your two options, 2 and 1/2. What do we think? 1/2. Outside things do not change. So I will keep it as is. And again, the whole do I change it or not, that's what's going to catch us. We got to slow down. Outside things are exactly what we think. We'll go down this column, multiply. Oh, I said 2, didn't I? Oh my God. 1/2. Outside things do not change. Try that again. I can actually write what I'm saying here. Okay. After multiply, we dot out our points, and then we look for anything that we would need to count. 0, 0, -1/2, -4, 1, -9, 1/2 really runs off my graph there, so I'm not going to be able to get that one there. And then I scan through and say, do I have any addition, subtraction? And I do. So we would do that. -2 on the inside, which direction? Right. So I'm going to take each of these points and move it to the right. 1, 2. Right, 1, 2. Right, 1, 2. And there would be my final graph. Okay, I already put ROY up here for us. Try to describe your shrink or stretch, and then don't forget about your right too. Okay, my first word, vertical or horizontal, I decide whether it is inside or outside, right? Outside is vertical, inside is horizontal, and we said it was outside, so you should have picked the word vertical. I multiplied by 1/2. So I use that number. I match my word to that. So 1/2 is a small number. I would say shrink. A vertical shrink by 1/2. Right 2. Questions? Okay. The generic functions that do not use our parent functions is not new to us. We've now seen this kind of throughout. But I will tell you, as you have multiple transformations to apply, especially if it involves ROXs or vertical and horizontal stretches and shrinks, I would translate the picture into a table and then treat it just like every other table from our parent functions that we have used. So what I would do first on this is just come over here, create an XY table from the nice pretty dots in this picture, which are -2, 0, 0, 3, 2, 0, 4, -3, and 6, 0. Now I don't have to change how I treat each of my transformations. So we start at that top box. Do I have any negatives? My answer is yes. My next question to myself would be, is it inside or outside? And we would say outside. And then I follow what it says in there. Outside negatives impact my Y column because everything outside impacts my Y column. So that would be an ROX that is impacting my Y column. And that tells me, if I follow the directions in my cheat sheet, to go down my Y column and change the sign on every number, which most of those are zeros, but on the ones that aren't zeros. Then I go to the next box, which is multiply, divide. We have a multiply. Inside or outside? Inside things impact my X column by the reciprocal. So that's a 2. I would multiply by its reciprocal 1/2. Go down that column, multiply. In our steps, we would be at step number 4, which says lightly dot those out and then count right, left, up, down, if we have any of those. So I would put those points in my picture. -1, 0 would be here. 0, -3. 1, 0. 2, 3. And 3, 0. And finally, go to any transformations that we have that are pluses and minuses. That is outside, which tells me I'm going to take each of those dots and move them up 1. So take each dot, move it up 1 spot. And our resulting picture was reflected over the x-axis, horizontally shrunk by 1/2. You see it got skinnier, and then moved up 1. Questions for me? We're going to skip. I had a second one of that variety, but I think we're going to skip as long as you can follow your steps. However, there is a special case that we need to talk about. We kind of saw a little bit of a preview to it earlier. Guys, you will not see this often, but I do want to just let you know that it exists, okay? And that is if you have more than one inside transformation. If you have more than one inside transformation, and that can be a horizontal shrink or stretch, an ROY, and it has to include a shift, otherwise this really doesn't matter. But if it also includes a shift, your shift will be incorrect unless you factor out the GCF, and I'll tell you why I put that in quotations in just a second. But if I were to like super fast look at these, I would say that we are moving left 12, left 2. Okay, that is incorrect. If you have a number in front of x that is not a plain 1, you actually have to factor that leading coefficient out to correctly see the shift in the graph. So I would pull that 3 out, which means I'm going through and dividing everything by 3, and I would have x plus 4. The correct shift for this would actually be left 4. Same thing over here, and that's why I kind of put GCF in quotations. Like -1's not a GCF. It doesn't have to be a factor of the second number like it was over here. You're just factoring out that leading coefficient is really what you're doing. So I would take a negative out of this, and if I go through and take a negative out of this, I would have a positive x and then a -2. Factoring out a negative changes the sign, and now I can see that I actually should move right 2. We saw this earlier, and this is how it's typically handed to us, is just done for us. This one was already factored out. A lot of times it is already factored out for you. When would I see this ever? I mean, this is a great bonus question, okay? Great bonus question on a quiz or a test is identifying when you need to factor that out. Fast forward to this spring when we're graphing trig graphs, that's actually going to happen to us quite often, and we're going to have to remember to factor it out. We just don't do it very often here, okay? Any questions? All right. We are going to skip our check for understanding today because I have your test to hand back to you, and so I want to make sure during our work time today we have enough time for that.